Okay, so as in the last video we have derived the formula for calculating the energy of the orbit, and that was the potential energy, right? Last video we have discussed about the kinetic energy, and the last video we have discussed about the potential energy. In today's video we are gonna calculate the total energy of the electron, right? So we gonna calculate the total energy as I have written here, right? We're gonna derive the formula for calculating the total energy. And total energy, now how many types of energy we have? We have two types of energies right here. We have one kinetic energy and another is potential energy, electrostatic potential energy. So we're gonna add those both. In the end we're gonna get our total energy, right? So for suppose here I have an electron. This is the electron I have, right? Electron. Of course this electron is moving, right? This electron is moving, and because of this motion we know that this electron has the kinetic energy, right? Wait, basically this energy is not of electron, however this energy is of shell, right? So it has kinetic energy. Kinetic energy due to motion, right? Let me write that. Due to motion. And other you know what, the energy we have here will be the electrostatic potential energy, since we have the two charges, right? The one charge is, for example, this is, we have Ze, which is basically Q1, right? And another charge we have here is Q2. Here is Q2, and there is a distance between them, right? This is basically the distance between these two charges, and this distance is represented by R, which is used here for radius, right? From the center. So this is basically, you know what, the electrostatic potential energy. There is an energy exists between these two charges, and that energy is known as electrostatic potential energy, right? Now we have derived the formula for calculating the electrostatic potential energy and the kinetic energy. Let me write here in this box what we have calculated. The kinetic energy of the shell is 13.6 into Z square upon N square electron volt. So let me write here. The kinetic energy is equal to 13.6. This is in the electron volt, not in the kilojoule per mole, right? In the kilojoule per mole, that would be 1313.135 into Z square upon N square. This is 13.6 into Z square upon N square, where Z represents the atomic number and N represents the shell number in the electron volt, right? Let me write this too, that what does Z represent. I have just told you verbally this, no need to write, right? Now let me write the potential energy here. The formula which we derive for the potential energy was minus 2 into 13.6 into Z square upon N square electron volt. And why this was in the negative sign? Since we know that attractive potential energy is always negative and the repulsive potential energy is always positive. So let me highlight this here. This is for the kinetic energy, right? and the down one is for the potential energy. Okay, so our today's task is to find the total energy of the shell, right? And we know that the total energy of the shell would be equal to what? The total energy will be equal to the kinetic energy plus the potential energy, right? Plus the potential energy. This is the formula for calculating the total energy of the electron. Not the electron but the shell. Okay, let me highlight this now with the yellow color. Now we know that what we have the kinetic energy, we have 13.6 into Z square upon N square electron volt. So let's write that here. It's 13.6. Wait, let me mention this here first. Kinetic energy is equal to 13.6 into Z square by N square electron volt. Let me write the potential energy here as well. So potential energy is equal to minus 2 into 13.6 into Z square by N square electron volt. Now let's add these both equations as I mentioned in the first one. To find the total energy, we need to add kinetic energy with the potential energy. So let's add these both. Total energy I am representing with TE is equal to kinetic energy we have is 13.6 into Z square by N square plus we have potential energy that is equal to minus 2 into 13.6 into Z square by N square electron volt, right? So now as you can see, this is plus minus minus, so of course let me go with that. Total energy is equal to 13.6 into Z square by N square minus 2 into 13 plus 6 into Z square by N square electron volt. Now let's see, when we're gonna multiply these terms, we're gonna get total energy is equal to minus 13.6 into Z square by N square. This will be the formula for finding the total energy. Let me write this here. This is the formula. This is the formula for finding the total energy, and that is equal to kinetic energy plus potential energy, right? So now let me highlight this too. What I found here basically is this, right? Kinetic energy, potential energy. Now let me highlight this last one, which is about the total energy formula, right? Okay, so this was all for today.